think we are recording now. So don't commit any crimes in the next hour or so that are audible, or else this may be evidence in court. Okay, cool. Shall we start? Are people geared up and ready to go? Everyone's pretty much laptopized. Does anybody? I mean, you kind of know this stuff. You have access to a laptop, or?
Yeah.
Okay.
I just don't have one.
That's cool. It's not like strictly necessary. It'll be good for following along, I think, in future weeks. Like I think I said in the email, if you don't have a laptop type thing, I think we have enough of those kinds of things that we can like share. As long as it's not more than 3 or 4 people. Today probably not super necessary because I think it's going to be more organizational and like super basic stuff. That probably, well, so let's see, by a show of hands or whatever. I know some of you were like in this before, have had some experience noodling. So who's got some experience playing around with Python at least a little bit from before? Okay, cool. So a fair number. And who's got some experience, if you haven't got experience in Python, who's got experience like fiddling around with something else that's not Python? All right. So like everyone's not total noobs to this, I guess, for the most part. But I think our plan for this semester, so what we kind of talked about last semester when we were trying to figure out how to do this stuff, was that it would help to have this as more of like a formalized class thing and to break it apart from like kind of the more expert-based discussion that we're having at the other meeting. And of course, people are welcome to do both. But that we would try to make this a little bit more about programming specifically, and I know some of you are taking this for credit. And what that means, I think, is that it's going to force, well, if you're taking it for credit, you kind of have to show up every week, or that's the plan. And I think that's going to let us get a little bit more into like actual programming rather than last semester, which was kind of like a whirlwind tour of what you can do with CyclePy and so on. So my hope for this was like focus a little bit more on fundamentals, which like, much like doing, that in sports or something like that, it's not always the flashiest way to learn stuff, but I think we're going to do better with getting people to actually be able to use this stuff. Okay, so before we jump into that, let me just quickly pop up a calendar here. So I think our plan was to meet like roughly every 3 out of every 4 weeks, and then oops, my little life hack of my pen died. Oh well. I thought I was very smart for putting a stylus tip on top of this pen, but it seems like the super glue has died. All right. I thought we could do like 3 weeks on and then like take a break in between, just so we're not like constantly meeting with this stuff. So does anybody? Basically, I just wanted to like forecast out. Does anybody see any major issues? Maybe let me pull up my personal calendar here on my display. So that would be like today, which is 125. If we just went 3 on and 1 off, so that would then be like February 1st. Anybody have an issue with February 1st? Foresee any major issues in their schedules? And then the next one would be February 8th, I suppose. Everybody good with February 8th? It's the day after Super Bowl Sunday. So we might all be suffering from like a wing overdose, but other than that, presumably that's okay. All right, and then we could maybe take a week off for, oh, well, that actually works out kind of because the 15th is President's Day / Washington's birthday and the day after Valentine's Day. So, if you want a nice, long, romantic.
So I don't know if this changes things for you or not, but
yep.
The week after that is spring break, so we're already off anyway.
Not in February. Months.
Nice try.
Yeah. No, yeah, but that's good to look out for. I haven't like gotten that far ahead to see how that syncs out. Okay, so yeah, maybe we'll take a break on 2/15 so that we can all have long, sexy, romantic weekends or celebrate president birthdays. And then that gives us, let's see, what are we up to? Yeah, so that's the 14th, 15th. Back on for the 22nd. That looks clear to me. We've got a cabin talk that day, like many of these weeks, but that doesn't interfere as it did not interfere today. Then we can meet on the rare February 29th. If that sounds all right to you guys, which is a real day this year. And no issues with March 6th either, I don't think. Anybody foreseeing any like major scheduling issues coming up for any of these? Oh, sorry, 7th. 7th, you're right. My brain was in a 365 day year. Okay, yeah. Or no, got it backwards. All right, so yes, the 7th looks clear. And then, yeah, actually, so what is it? It's the 2 weeks after that is spring vacation. So maybe we do like 4 in a row and do the 14th. Oh, Pi Day. I got to have a programming meeting on Pi Day. Yeah, we can do all kinds of. Oh, I can already think of the exercises we can do for Pi Day. We can even do some of that today, potentially. Okay, so maybe we'll meet on Pi Day and then like give it a rest for spring break anyway on 3/21, so we can all go to Mexico and enjoy our tequila. So yeah, I think off on 3/21, and then let's see. So I guess this is not like showing you very much because it's a blank calendar, but just to orient you. So let's see, 3/28 is the day after. Is Easter Monday like an official university holiday? It's not, right, for any employees or anything. So I didn't think it would be. So all right, so we can be back on presumably for 3/28. Oops. And for 4. And for 11, nobody see any issues with that?
I won't be here on the 28th, but we'll need to change the
Okay. Still going to be spring breaking. Okay. I was going to make a really stupid joke about, well, if no Juan's going to be here that day.
Never heard that
Yeah, I'm sure you've gotten them all before. All right, no, but yeah, we'll probably go ahead with it, I suppose. All right, and then like 4/11, and then maybe we'll play it by ear after that. Just like, I mean, we'll probably try to do another cycle before the semester's over. But those basically work for everybody. So if we're on January 25th, let's see, get this over here. Yeah, so on January 25th, February 1st, February 8th, off February 15th, on the 22nd, 29th, March 7th, and March 14th, off the 21st for spring break, and then on the next 3 weeks, March 28th, April 4th, and April 11th. All those sound good to people? And then we'll probably do another skip in 3 more weeks, but like maybe leave some flex to plan out in advance in case stuff comes up. Okay, cool. Everybody on board? Feeling good? All right. Well, in that case, I will put that. We'll probably make like a little web page like we did for the last semester's thing. I actually kind of have a template from the other class I'm teaching right now. So we'll probably like make a little web page and send it out for you guys, just with like these recordings and any notes or anything if you miss stuff, or if you want to go back and check stuff out. So we'll put the schedule up on that web page and send around so you can have it for your reference. But let's plan on that for now. All right. So task 1 done. All right. Now, everybody excited about Python? Yay. So I think the plan for today, I didn't want to waste a bunch of time talking about like getting Python on your computer, because that's going to be a very individualized experience for everyone. If you have a Mac, because you are smart, or if you have Linux because you're even smarter, and like dealing with drivers and things a lot, you probably already have Python on your computer. If you are on a PC, which looks like a good half of us or so are, it may not be on there by default unless you were already sufficiently enough of a nerd to put it on there in some way. If you're on a PC and have not done a lot of this before, my recommendation that we did last semester was just to install Psycho. Did I spell that right? I probably did not spell that right at all. PsychoPy. Which is like, for those who have used it before, a stimulus delivery program that people use for cognitive psychology stuff and cognitive neuroscience. We're not going to be talking about like the PsychoPy specific stuff for presenting stimuli unless we maybe do that late in the course. But it does include a full Python installation. It's pretty easy to run and use. So if you're on Windows and haven't done a lot of this before, that's my recommendation. If you want to like rock it hardcore and do it all in the command line or something, then there's other ways we can go. But maybe we'll leave a couple minutes at the end of class just to like chat about that and kind of short today. So anyway, if you're on a Mac, you'll get to see what I'm about to do, and you can do the same thing. If you're on a Linux machine, you can do the kind of parallel thing. If you're on Windows, today, if you don't have it already installed, like you can try to install it right now real quick. You just kind of go to the download link and get the latest stable version. If you don't, you can do that offline. I think we won't be doing so much today that you need to super follow along with it right now.
Is
Okay.
Python for SPSS usable? It just came with my SPSS.
I don't even know what that is. What are you on? Are you on a Mac?
Yeah.
If you're on a Mac, you already have, I don't know what it does. It's probably like some Python code that integrates with SPSS. But you've already got it like by default, so you're okay.
Where?
All right. So excellent question. All right. So if you are on a Mac or Windows, a Mac or Linux, you certainly have access to a terminal, a command line terminal, which, like, if you don't use this stuff all the time, looks kind of scary. We're not going to spend a ton of time in it, but I figured I'd start out in the terminal just because that's an easy way to launch Python. So if your terminal may not look like this because I have mine all like Apple IIified, so it's like green text on a black background. I think by default it's black text on white. But if you're on one of those two things, you can open up a terminal window. Presumably, if you're running Linux, you know how to open up a terminal window. If you are on Windows and you do have PsychoPy installed, you can get the same experience by launching PsychoPy. And if you haven't used PsychoPy before, it's got these various little like tabs and panes, most of which are, it's coming up on the screen. Most of which are used for more, what are you doing? It really does not want to let me drag the PsychoPy window. There we go. So you've got these kind of, in the coder view, it's got the like builder view and the coder view, which I always, we don't care about the builder view, but in the coder view, it's got a little place up top where you can edit code, and it's got a little output panel down here, but what you really want is the shell if you're running PsychoPy, which will give you the same experience as what we're about to do on the command line in regular Python. So actually, just to prove that to you, if you're on a Mac or Linux, what you can do if you're on a command line in the terminal is just type Python, and that gets you into, so this is the first thing to discuss is what is Python, right? Hopefully you'll see something like that, right, which looks more or less like the text that's in the PsychoPy window, right, telling you the version of Python and so on. So Python is primarily what we call the programming language, right? The language of Python, the syntax and the words that you use to make the computer do stuff. But the way that Python works is it's what we call an interpreted programming language, which means that, so I don't want to get into the whole distinction, but like there are two major kinds of programming languages in this sense. One is compiled and one is interpreted. Compiled programming languages, and they're not mutually exclusive, but when you compile code, what you do is the human readable code that you write in text is not what the computer is actually running behind the scenes, right? Like every time you launch like Microsoft Word, there isn't a big text file that it's reading somewhere like with instructions, right? The computer uses a much more condensed format for the actual instructions that it's running, right? And your instructions that you're entering in human readable text are just kind of like a higher level representation of what will eventually be what the computer does, right? So if you compile your code, that's like when you make a real app like Word or some kind of phone app or whatever, right? That like is just always computer code. It just sits on your computer as runnable computer language. And that's how it works, right? Now, Python is not that most of the time. Python is interpreted, which means that you never really like make the code something that is self-contained the way that Microsoft Word is. You always have like a text file, and what you have to run is a program called an interpreter that reads that text and translates it into machine language like as you're running, right? So the processes are very similar. This may be very abstract to you guys. You don't have to worry about the distinction too much, but basically like in both the cases of compiling and interpreting, you are running something that translates your like human readable text into something the computer can actually do, right? The difference being compiled does that like once and then leaves the computer code for you to run every other time, or the computer instructions for you to run every other time without needing the original source code. Interpreted languages, you're basically like telling it to read and interpret the source code every time individually. Okay, why does that matter? The only reason that matters is because what we're doing right now, when we launch Python on the command line like this, or in CyclePy like this, is we are running the Python interpreter program, right? So this is like the program named Python that interprets Python code that you give it, right? And we'll see later there's a couple different ways you can do this, but one thing you can do is just type Python code right into the Python interpreter, okay? Now another way to do it is to give it a file, like a text file full of Python code, and it will like just do all the stuff in that text file. But right now what we're doing is we're just going to enter commands straight into it in the Python language just to like kind of get our bearings. Does that make sense to everybody? Does anybody have any questions about these general ideas before we kind of launch further? All right, so if you have Python already, you can go ahead and launch a Python interpreter or launch the Python program, however you see fit, either here or in CyclePy. And we're going to play around with it a little bit just to like get your kind of footing down on what Python is. Okay. So let's start with some let's do what is traditional for every programming language ever as like the first program you ever write. And let's try this statement. If you can, I don't know if you can read this very well.
Can you zoom in?
Yeah, let me, I don't know how, I might script the screen recording to like change the resolution on the fly. But let me just, let's do this. In future iterations, perhaps I can, weird. Oh, that's freaky. It's, all right, when I zoom like that, it kind of goes onto my other display. All right, that works pretty well though. All right. So yeah, in future iterations, maybe I'll run this at lower resolution. But for now, you've got this, right? So I've typed print hello world, and I've enclosed hello world in quotation marks. And it prints out, well, what does that command do? This is my cookie eating break using the, fun fact, the Socratic method was actually so Socrates could have cookie breaks. So all right, so what does that do when I do print hello world?
Puts the text that's between the parentheses on the next one.
Mm-hmm.
And effectively prints it.
Yep, it prints it out to the screen, right? Now, what you may have already seen, so what is the main distinction between what I typed on that print statement and what it actually printed out on the screen? Right, I put in quotes, it did not put that in quotes, right? So it's not interpreting this literally. By the way, this is something that I never think to talk about, but obviously in like programming language world, usually print means like right on the screen, not like print to a piece of paper the way that usually print means, right? Okay, right, so we put that in quotes. So what would happen if instead I just say, I don't have to type the whole thing. Okay, it is not like that, right? Our first error that we have encountered in our illustrious programming career. Okay, so clearly those quotes are important, right? Because we get some kind of weird error if we don't have quotes, but that is totally okay, right? Okay, so this is, well, we'll get to this in a second. So these quotes are important because in Python, you're going to be defining lots of names for things, right? Um, so actually, let's go ahead and do this right now, and you can see how this works. So let's make something like this. That seems like a weird thing to say, right? Hello equals 5. It seems like a very odd thing to say. But now let's see what happens if I type. All right. So if you had some programming expertise, this may be obvious to you, but if not, it may not be obvious. So those last 2 lines of code, what did that do, and why is it now letting me print hello in lowercase now for convenience? I mean, it let me say that. It didn't give me an error, but it printed out the number 5 when I told it to do that. So why is that? What are we doing in those 2 lines of code, does it look like?
You defined hello.
Mm-hmm. All right, so I defined a name for something called hello, and what does hello represent now? Yeah, like the number 5, right? So I think Rave or somebody said this. So yeah, that's what we call a variable, right? So you can think of this like, if this is totally unfamiliar to you, you can think of it sort of like in algebra class where you have, traditionally like, you say something like x equals 3 or something like that, right? With the main difference being like usually in algebra class, the point of naming numbers or things with letters, and it doesn't have to be single letters, right? It can also be whole words. We saw like hello. The point in like algebra class is that these things can take on a lot of values, right? So you'll have something like x equals y plus 5 or something like that, right? But that means, in algebra class that x and y can be anything as long as x is 5 more than y, right? So we use kind of a similar syntax or a similar format in programming, but what is called a variable, right, like the text that represents a number or a value, it's only variable in the sense of like we could change it later if we wanted to, right? So I could say like x equals 3, but I could also say like later on x equals 4. And if I say print x, it prints the current value. So we can like change the value of what this name means, sort of the way it changes in algebra class, but at any point in time, it's stable, right? Does that distinction make sense to everybody? So like in algebra class, when you say x equals y plus 5 or whatever, that refers to like a range of things that x and y can be. Like in programming, we are basically assigning a name to a value, and that assignment stays stable as long as you don't explicitly change it. Does that kind of make sense? So a way to think about this is when we say like hello equals 5 or x equals 4, what we're doing is we're kind of defining a name, right? And we are defining the thing that name refers to, right? So, when you get a new puppy, you have to decide what to name it, and you name it Spot or whatever, and that would be like saying Spot equals like that dog over there, right? In sort of programming parlance, right? So, if the number 5 is our new puppy, it needs a name so that we can refer to it not as just the new puppy all the time, so we can refer to it by its name, right? And so we say something like hello equals 5, right? So then we can just call this number by its name and not refer to it as 5 all the time, right? So then, if that puppy dies, or if we want to just like, sorry, dead puppy's coming in unusually early in the class this time. So, yeah, usually it's like the 3rd lecture. So yeah, if we, or let's say we just don't like, well, let's say we, don't like Spot anymore, but we like the name Spot. We just like don't like that dog, right? So we send him away to live in the countryside somewhere, and we want to get a new puppy, but call it by the same name and pretend, or like when your goldfish dies, right? And your parents like surreptitiously replace the old goldfish with a new identical looking goldfish that they call by the same name, so you don't have to learn about death too early, right? So we could always like rename our little buddy, and give it a different value, right? So make that name refer to a different thing or a different number, so that now if I print hello, that name refers to a different value, right? Okay, so there's a lot here to unpack if this is not familiar to you yet, right? So essentially what we're doing here when we say something equals something else, again, this is a sort of tricky thing if you're used to like the math sense of the equal sign, because when you say equals in math, like if you say x equals y plus 5 or something, that is a statement for like all eternity effectively, right? You're saying that like for any value, like x can be anything as long as it's equal to, you know, some value of y plus 5, right? So there are like many pairs of x's and y's that fit those requirements, right? In programming, that equality you're saying is like you are making two things be equal to each other. You are saying make it so that these two things are equal to one another at this point in time, right? But we can always change this. So in other words, we're saying like, all right, I've got this name hello, and I want that to be equal to the number 7, or I want that to be equivalent to the number 7, but I can change that at any time, right? Like that equality is more about, kind of the analogy we use a lot is like a box, right? So I've got a little box, and I've got a bunch of potential boxes. I have as many boxes as I want. I live in a box factory. But for these boxes to be useful, right, you got to like put something on the outside of them that says what's in them, right? So you can think of our box as this word hello, right? So we've got a box and it's labeled hello, and we can put different things in the box, right? That equality statement is just putting number 7 in the box, but if we wanted to, we could put the number 5 in the box. We could put a bunch of other stuff in the box, right? But it's all in that box named hello, right? Everybody cool with this so far? Any questions about variables or naming stuff or assignment or anything like that?
So just like the advantage of this approach is that it feels like a lot of code, and you had to change like one thing. You don't have to change it like 100 times. You just like change one thing, or change it like all over.
Well, right. So there are a lot of reasons that this is going to be useful, right? That's definitely one of them, right? So like, let's say let's say you're programming a psychology experiment or something like that, and you want your stimuli to last for 200 milliseconds. So you have this number 200 that's going to be important in your code, right? And maybe it's going to come up a lot in your code because you're going to have a lot of different kinds of stimuli. You're going to be presenting and taking them off the screen a whole bunch. So you might have occasion to use this number 200 like dozens of times in your code. So one reason to use a variable or a name for this number is that let's say you then change your experiment and you want the stimuli to be on screen for 300 milliseconds. So if you just literally use the number 200 every time you needed something to happen for 200 milliseconds, then when you need to change things, you have to edit your code and like do a find and replace, and every single instance of the number 200 you replace with the number 300, right? Which is like both inefficient and potentially leads you to problems because you can't just do that wholesale necessarily, because maybe you use the number 200 for something else. You know, maybe there's also like 200 trials and you don't want that to change. You only want the duration of each thing to change, right? So you can't just like dumbly find and replace every 200 to 300. You have to like go through and hunt. So that's one reason, right? Is if you give the number a name, so you call it something like presentation time equals 200 or something like that, then instead of the number 200 every time you need to refer to how long that item is on screen, you can just use its name, presentation time. And then if you ever want to change your code, you really just have to change that one line that initially sets up the value of presentation time. And you know, then every time that you use that name elsewhere in your script, it just substitutes in the current value of presentation time, right? By the way, you notice I put an underscore there, so that all counts as, underscore counts as a letter, right? So what we can't do, let's try this. All right, so it doesn't like that at all. Invalid syntax, a common refrain. So that means that doesn't make, so invalid syntax basically means like I cannot interpret what you said, right? Syntax being like the rules of a language, including both a human language and a programming language. So if you get invalid syntax, that means like that is not a valid way to say stuff in Python, right? Because we use spaces like we do in English to separate important values or important think of it like in English, like if you just had a comma in the middle of a sentence where it doesn't belong, like that would be weird, right? Like that would, we use commas to separate certain types of things, but you can't just stick it anywhere, right? So in programming, like one of the most important things we use to separate out different characters is spaces, right? And so if we have a space here, that could refer to one thing that altogether means presentation time, or it could mean two different things called presentation and time, right? And because we are smart humans, we can maybe like infer what that means. But if you're a dumb programming language that just has a very limited set of rules that it uses to interpret statements, like it could not figure that out, right? Okay, so spaces are important. You can't just have spaces everywhere. That's why I use the underscore. Now, anyway, so that's one value of using variables is you can like easily refer to it multiple times without having to like use the exact, what we call the literal value every time, right? Right, and again, just think of it like the dog or the box with the label on it, right? Like then you can just say like, you know, refer to Spot every time you need to talk about the dog, not like the dog that we bought on December 14th, 2007 or something like that, right? You can just kind of like use it's a short name for something. Now the other reason that these variables are useful, and probably the more powerful reason overall, is that sometimes you want to treat a number or some other kind of value similarly, even though its actual value might change, okay? So like, let's say, again, you're doing some kind of psychology experiment, and the duration that the thing is on screen might change between 200 milliseconds, 300 milliseconds, 400 milliseconds for different trials, right? Maybe you just kind of randomly assign the presentation time. So it would be sort of weird if you had to write separate code for doing the same basic thing and only changing how long the thing is on screen, right? So what makes more sense is to just set a value, you know, like let's say we have some part of our code that handles waiting, you know, 200 milliseconds and then taking the thing off screen. It'd be weird if we had to like figure out some way to do that differently for different numbers when all we really want to say is like, however long we're supposed to wait that long, right? And that's what variables let you do, right? You can just set this, this value to be different things at different times. And then when you have a function that says like, wait however long presentation time is, it doesn't really matter what that number is, it'll just do it appropriately, right? It'll substitute in. So another way to think of this is, in a sort of algebraic sense, is when you have a name for something, what it's doing is essentially substituting, it's looking up the value and it's, you know, it's substituting whatever that value is in a kind of algebraic sense. So like, here's an example. So let's go back to hello. So let's see what hello is again. It's 7 right now, right? So I know we're getting a little bit ahead of ourselves, but that's all right. So what if I said, and I know we haven't introduced this stuff formally yet, what if I said something like that? What do you guys think will print here? 12, right? All right, let's see if that's true. Okay, so as you correctly intuited, if you didn't already know this, things like parentheses and pluses work the same as in Python as they do in math, right? So what you're doing here is when Python sees the word hello, it kind of looks up to see if you've already named like a little box or, you know, given the name hello to something, and it sees, oh, okay, yes, they have set hello to be the number 7. So when it sees a statement like this, hello plus 5, what it does is it says, all right, well, hello is the same as 7, so I'm just gonna, like, if you remember back in algebra class where you would like kind of cross things out and like write in their values to kind of check your work or whatever, you know, it just does some basic substitution and says, all right, that means 7 plus 5. 7 plus 5 evaluates to 12, and so what I print is 12. Is that everybody kind of on board with that basic idea? So this whole variable thing lets us be very flexible, right? It lets us use names for things that can change over time, right? Using, you know, so like if you are using like the box analogy, I'm trying to think of a good example. So let's say you had a box labeled like my favorite shoes. So, if you told, let's say you have, I tell Rafi to do this all the time. You have some employee or somebody that works with you, and you say like, "Oh, get my favorite shoes from the favorite shoes box." Like they'll go to that box and like bring back to you like your favorite shoes, right? But the exact shoes in your box might change over time, right? So no matter what's in that box, like that person's going to bring back the stuff that's in that box, right? So that's useful, right? Because maybe I have some kind of workflow in the morning where what I do when I get dressed is on most days, my pattern for getting ready for work is to put on whatever shoes are my favorite shoes at the time, right? So I go to the favorite shoes box that I have in my house, and I look inside and I grab the shoes that are in there, and maybe those change over time. But whatever's in there, like my method for getting dressed is to put on whatever shoes are labeled as the favorite shoes, right, and wear those. Is that like making this idea of variables make sense to people if this is kind of foreign to you? Okay.
What's the difference between printing just hello and print hello?
Ah, excellent. So yes, getting back to this is getting back to like closing the thread that we kind of started. So right. So what is the difference between print? So let's just do it all lowercase now, and sorry, I gotta scroll down a bit. And
No, I just meant without.
oh, without, sorry, did I do this without the
Like
print
you
somewhere?
just write hello.
Oh, if I just write,
Is there any difference between print hello and that?
well, there is in the sense of, like right now we are kind of running the Python program interactively where it's like looking at everything we say and doing it as we say it. So when you are running Python in that way, its default behavior whenever you type a statement is to print out the result of that statement. You know what I mean? So like when you're kind of running Python interactively like this, there's kind of an implied print statement at the end of everything you type. So I was kind of trying to kind of avoid that for the moment. But in other words, like when you run it non-interactively, so when you do the thing where you give it a file full of code and tell it just to like run all this stuff, it knows it doesn't need to print out the result of everything you're doing for every line of code.
Unless
Yeah, right, unless you say print, which specifically means like print this out to whatever console or whatever you're running on.
So
But yeah.
because hello is already defined, it knows what it is. So we can type hello without having print, and it'll say so.
Right, because hello has a value now. So that's why I kind of put I just put hi there, and we haven't defined a value or a behavior or anything for hi. So it doesn't know what hi means, right? That's not a word that Python recognizes. So that doesn't work. But yeah, because hello equals 7, we could also just write 7 and it would tell me 7, right? Because it's just printing out by default the result of whatever that statement is. Or if you type in 3 plus 5, it'll give you 8, right? Because it calculates that result and prints it out for you by default.
Would it be easier for me to write second time jump or that's what both the environments and same.
Well, yeah, so we could do it this way. That's a good point. Let's see if I can switch back to CyclePy. All right, so let's zoom out a little bit. This is weird when you do the zoom thing with multiple desktops because it's kind of showing this on every desktop. All right, I'll just zoom out all the way for the moment. Hopefully you can still read this. So, right, so if we do it in the Python coder, this is basically how it works. It's jumping ahead a little bit, but that's okay. So here we can do the thing like 3 plus 5, right? And that'll print out 8, and that's the same thing as if we print 3 plus 5. I didn't bother to put spaces in that time, but it's the same thing. Right, it does that. Now, if I instead start a code file, basically I have to save this on my computer somewhere, right? So if I say print 3 plus 5, and can everyone read that? Let me see if I can zoom in a little bit. All right, so if I save this very simple Python program as a file on my computer, that's fine for now. All right, so now I've got a file called untitled.py, which is, it's got a different extension than txt, but it's just a text file, right? It's just a text file that is demarcated by its extension as being specifically Python code. All right, so if I go instead to the output thing, and I click the little run button, which makes Python run in non-interactive mode, it just prints a series of things, or it just runs a series of statements that are in this file. The output we get is 8, right? And if I were to put in multiple lines of code, like print hello, and save the file and run this file again, it'll do both of those statements in order, right? But if I then put, let's see if, I actually don't know what this will do. I just run this with the extra line of code in there. All right, it doesn't print 3 plus 5, right? Because it's not like running interactively, it's just doing this stuff. So the difference is, right, I explicitly told it to print those things in the first 2 lines of this code file. In the third line of the code file, I didn't tell it to do anything, right? So it like does that math, but then it just throws away the result because I didn't put in a variable, I didn't like assign it anywhere, you know, I didn't do anything with it. Now I could do something like hello equals 3 plus 5. Now if I run that, so I just have to zoom out again, I think. It still doesn't print anything, right? Because I made hello, I made this kind of little box named hello, and I put the value of 8 in it, right? Or the value of 3 plus 5. But now if I say print hello at the end of this code, and run that, I get that 8. Does that kind of make sense to folks? So yeah, the main difference is if you're kind of running it interactively like here, which is the same as running it interactively, you know, in the green screen. Yeah, if you have something that like creates a result, it automatically prints it out at the end of doing that thing. But if you scroll right very carefully, well, let's do this. All right, so yeah, that's the main difference. And again, I sort of was not going to get into like running actual code files for a little bit, but that's cool. Okay. All right, so your head may be swimming a little bit if this is new to you. What time is it? Oh, so much time, so little to do. Okay. So the main things we want to come away with for right now, though, are this. We have defined back in here. Now, this may be confusing, I guess, because we were like in CyclePy, now we're back in here. These two, like, everyone's cool that, like, CyclePy doesn't know about what I'm doing here in the green screen, right? Like, even though I kind of use some of the same words and stuff, like, they don't know about each other. Just like a file you have open in Word doesn't know about a file that you have open in Pages or something, right? So this is not global for the whole computer. This is like just within this little session that I run right on each screen. Should have probably used different names to make that clear. Okay, so we know what this word hello represents right now, right? It's number 7. Going back to what Juan said and what we kind of start out with, what's the difference between those two things?
If you have the quotations, it's like is a string variable like this? If it thinks it's a string or it's not numerical.
Right. So quotation marks are a special thing in Python and most programming languages that mean like instead of treating it's basically like using air quotes when you speak, right? Like, you know, if I say trying to think of a non-offensive thing to make air quotes around presidential candidate Donald Trump, you know, or something like that, right? Yeah, so like you're basically putting like little air quotes around it. You're saying like, all right, this is like I'm treating this. I don't necessarily want to use this name or this text as a name for a real thing. Like I want to just refer to those words, right? I want to refer to that string of text. You know, again, it's like having a box, right? Like there's a difference between the box labeled favorite shoes, which sort of by default, if I say like, you know, get my favorite shoes, you go get my favorite shoes. If you instead have like a book named My Favorite Shoes, you have to say like get quotation marks my favorite shoes, right? Like it's a difference between reading the words as what they refer to and reading the words as just words, right? All right, which leads to this. And you kind of jumped ahead with this, but this is where we were going. So yes, this is exactly what I was trying to build up to. All right, so now it let me do this, right? It let me say greeting equals parentheses hello. So what do we think is going to happen when I say this? Should just print the word hello, right? Okay.
If you put quotations around greeting, would it then print greeting? Or would it print
Now what do you guys think? Yes, great. Right. Because, all right, so the quotation marks mean like, treat this, like don't read this thing as having meaning, just read it as like literal text, right? So right, if you say print greeting, I feel like there's like a who's on first or kind of, yeah, this is very much like who's on first, right? Like I have this first baseman named Who, and who's on first? And you know, the whole joke of that, right, is like the name Who, which refers to a baseball player, versus the word Who, which should be used as a regular word, right? So it's kind of like that, right? Okay, so what do we know so far? We know that strings of text, which I use that phrase very specifically because in programming speak, a chunk of text is called a string, just because like, you know, text is string-like, right? It's like a string of characters, right? So, you know, if we could have a longer greeting like, you know, something like that, and that works fine, right? So that's a whole string of text with more characters in it, right? It doesn't have to be just one word or anything like that. And you notice that, by the way, when I put it in quotation marks, it's totally cool to have spaces and stuff, right? Because like spaces are totally valid to have in like just a chunk of written language. So that's cool, right? And then greeting, the word greeting then refers to that whole string of text, right? So what do we know? We know that strings, or like text, are represented by stuff surrounded in quotes, and that we can assign names so far to both numbers and strings, right? So, you know, if you lived in some weird parallel culture where people talked in numbers, you know, like you could assign that variable greeting to a number instead or something like that, right? So you don't have to remember this term because this is a more like high-level programming term, but when you refer to a value by like what it actually is, like the number 72 or this like string of text, that's what we call a literal, right? So that means like it's the kind of opposite of a variable, right? So a variable is a name for something. A literal is the thing itself, right? So what we've done here, for example, with like greeting equals 72, is we have defined a new variable named greeting and assigned it the literal value of 72, right? Because like 72 is not a variable, right? 72 means 72. Like you can't rename 72 to something else, right? Like it literally is the number 72. Whereas the word greeting is just a word for something, right? Or just a name for that kind of box or that, you know, whatever is being stored in that name. And it can change, right? So that's variable versus literal, right? So we have a couple different types of literals so far, numbers and text. And we have the idea of variables that can like be assigned to these literal values. Okay. What doesn't make sense so far? Anybody confused or questioning things?
You can put anything you want in the code, right? Including numbers.
Oh yeah, so that's actually a great question. So let's just keep calling it greeting, even though it's no longer, you know, this is very bad like programming style because normally it makes sense to name your variables something descriptive. But what if we said greeting equals 72 in quotes in a reasonable programming language like Python, not a stupid programming language like JavaScript that tries to do all kinds of dumb stuff? What happens now if I say print greeting? What do I, well actually that's, well what's going to happen?
Will I give you 72 in simple text?
Well, it'll just give me 72 again, but here's the difference. What happens if I try to do this? What do we think?
It's going to error because Strata had what it thinks is a string variable.
Excellent. And that is what that error is basically saying in slightly nerdier language, right? Is if I said greeting equals 72, just the number, then greeting plus 5, that's totally fine, right? 70, because then, now that I've changed greeting to be the number 72, 70, when I say greeting plus 5, it just sees greeting. It says, all right, let me look up what that means. That means 72. 72 plus 5 is 77. But if we go back a couple lines, I can hit up, by the way. That's a little pro tip. If you hit up, it gives you your previous commands. We go back to where we said greeting equals the text of the number 72 and try to do greeting plus 5. It says, what are you talking about? That makes no more sense than adding, Bob plus 72, or hello, my name is Jimmy plus 70 or plus 5. You know what I mean? Like, you can't add text to numbers. Does that make sense, everybody? I feel like I refer way too often to that in the Greek painting. They're like, this is not a pipe painting, right? Like, there's a difference between the representation of the thing or the name of the thing and the thing itself, right? So like the text 72, when you read it as a human, you like know that that means the number 72, but the written, it's like seeing it printed on a piece of paper, right? Like it isn't the same thing as the number 72 to the computer, the text of the number 72, right? Even though when you print it, it converts that number to what looks like to your eyes, the number 72. That's probably more confusing than it needed to be. Okay. Everybody cool so far? Anybody else got any like major questions about variables and names and numbers versus strings?
With Python, can you check what kind of variable, is there something you can use to check what a variable is? If not,
You can. I can't remember exactly what it is right now. Let me look that up. Yeah, but you can check what kind of thing it is. So the reason Jeff is asking this is like, perhaps you intuitively see that like, there's a difference between a thing that represents a string or text and a thing that represents a number, right? So it can be useful to like look and see whether a name refers to a string or a number. Python can do that. There are other languages where you have to like explicitly define whether certain names refer to numbers or strings before you can go any further. Python just kind of infers that from what you assign it to be. I forget exactly how you introspect that because I don't use it very much, but we can look that up. Yeah. Somebody else had a thought or a question? Yeah.
Sort of a related question. SAS has this like line of code that will print every variable that you created and tells you everything you need to know about that variable and all variables. Is there something similar to that?
You guys are going.
Print off every variable that you created.
You guys are going super high level, but yes, there is. Let's see. There's like. I'm trying to remember what it. Okay. Yeah. So there is. I mean, this is like kind of. This is more high level stuff, and I sort of don't use it very much. But you can see there's this function called dir, which is basically giving me like a directory of all the stuff that's currently defined. And you see there's some stuff that we actually didn't type in that's kind of like that Python defines itself kind of behind the scenes, these things with underscores. But it does tell us like all the names of all the variables that we have defined so far, right? So if I wanted to make another variable called spot or something like that, some dog. And if I do dir again now, you'll see that spot is on our list of things we define. So that will tell you kind of all the variables that are currently in existence, that currently have names. And then there's ways you can get more info about that stuff. I forget exactly what it is. Like there's ways that you can get it to tell you whether it's a string or whether it's a number or whatever. But off the top of my head, I forget what it is. We can look that up later. Yes.
I think if you just type the variable and not say print, if it's a string, like even if it's a number, the string will have two parentheses around it. And if you
Well, I found that in Stack Overflow, it says if you type parentheses in variable.
Oh, is that what it is? Yeah, because if we do like
Someone used it.
this, whoops. I'm reading. What did I do? If we type that and we just do greeting, it just prints it. But if it's type. Okay, so that tells us it's a string. Stir is short for string, whereas if I say thanks. Now if I do type greeting now, okay, it tells us it's an integer. Which actually, so we don't have a ton of time. We were going to wrap up by 3. Maybe I'll just tease you with this last little bit, which is what I was hoping to get to. So let's think a little bit. We'll get to more of this later. So we already did a little bit of math with these variables, or with like literal numbers. So we've seen that you can do stuff like 4 plus 3, you get 7. You do 4 minus 1, you get 3, right? You do your basic math. You can do 4 divided by 2. That's cool. We can make a variable called the number 4. Set that to 4 and say the number 4 divided by 2. That's 2. I mean, there's no rule that says you can't set the number 4 equal to 5. I know if I want to put that. That's 5. What? Like 1984 here. Here's a question. Oh, so I should mention, like, in case this wasn't clear, like, probably everyone's seen this in some form before, but if I do like 4 times 2, like asterisk means times in most programming languages, and 4/2, that means divide, just like you're making a fraction 4 over 2, right? So that's your multiply and divide operators. Now what happens if I do 5 divided by 2? What's the answer to that expression? Okay, you would think it would be 2.5. But what? It's only 2. All right, so we'll leave you with this as a little bit of a mystery, but just to like partially resolve the mystery for now, if I put in 5.0 divided by 2, I get the right answer. All right, this may like blow your mind holes if you've not seen this before in Python. It's a good question. No, we'll talk about that more later because I do want to like stay semi on time. But just to prove this to you, or not to prove it to you, or to give you a hint based on what we just saw, if I set the number 5, or the word 5 to represent 5, the integer, and try to divide it by 2, it gives me just 2. If I set 5, the word, to represent 5.0, and do 5 for 2, it gives me the right answer. Now if I do that trick that we just looked up on Stack Overflow, it tells me float, something different than an int or a string. You don't have to know what a float is right now. Maybe that'll be the cliffhanger that we will end on. Maybe next time we'll pick up from right here and talk a little bit more about different variable types and what you can do with them. But yeah, good chat. Went a little deeper into some stuff. Didn't go into some stuff yet, but that's cool as long as we kind of all are understanding what we're doing so far. Any other like questions or confusions before we kind of wrap up the formal part of the show and stop the recording? We can keep chatting after this, but if you want anything else on the record, now's the time. All right. Well, so agenda for next time. Just enough battery to save and get out of here.